All right, and now we have started recording. And welcome, everyone. I'm happy to welcome you to our DataGrok developers meetings. So this is a series of meetings that we are starting mostly for developers, and by developers I mean more like power users, essentially for people interested in extending or customizing DataGrok in any way. So we are not sure how much interest these meetings will have. So we are quite flexible and we might readjust. So perhaps we'll do a user meeting one time and then developers meeting the other time, or we'll split some other ways. But anyway, let's see how it goes. So I see 29 people in the meeting. This is great. So I think we probably will not do introductions since there are so many of us. So I see people from some big pharma companies. I see plenty of former colleagues and current colleagues, friends, and other people. So yeah, it's great to see everyone. I hope this community will go on. So speaking about the community, perhaps a good way for us to communicate and to ask questions and have your questions answered is by using our community. It's community.datagrok.ai. Oops. Sorry, my camera is covering the top part of the screen. So this is a good place to ask questions, get answers, but also get together with other people interested in the platform. So highly recommended. We are going to have one topic per each meeting. So this is the topic for the current meeting with the agenda. So I suggest for us all to contribute content, ask questions either in this topic related to these meetings or in the adjacent topics. All right. So today we are going to talk about different possibilities for customizing the platform and different options for extending it with behaviors, functions, or applications. So this will not be a hands-on workshop, but you will get an idea, a broad sense of what's possible with the platform and how to approach it and where to ask for help if necessary. So we do have an agenda, so we are going to cover a number of topics. So please interrupt me at any time to ask the clarifying questions. But yeah, keep in mind that we will come to discuss the other topics as well. So we should also think about how much time we have left. All right, so are there any questions on agenda before we start, or should I go on? All right, so no questions, so I'm continuing. So in this session, we will not cover the basic of what data grok is. If we are assuming that you are already familiar in some sense with the possibilities of the platform. But if you need some help, there are some links in the document that will get distributed in the end. Yeah, you can use them and go and see it for yourself. We have the platform with the online help, public repository of plugins, YouTube, community, and other channels. All right. So what exactly can we do with data grok in terms of extending it? So I'd like you to think about data grok as an operating system for data. So just like any other operating system, like Linux takes care about low-level stuff, files, pipes, messages, and so on. Data grok takes care of data and everything related to data science. So it makes developers highly productive and it offers a number of high-quality blocks that work really well together. And all of these blocks can be controlled, and many of them can be extended in a number of different ways. So just of the main blocks are our high-performance data engine, and as you know, it's extremely powerful. It can handle up to 100 million rows working interactively with it in the browser, or a million of columns. We have really fast visualizations that work directly with our data engine. We have all sorts of data connectivity. Essentially, if anything has an API, you can work with it. Databases, web services, files, file shares, you name it. We have great support for scientific computing, and that includes support for scripting and also support for different predictive model engines and other commonly used things. A number of routines are being offered out of the box that are related to data science, machine learning, and artificial intelligence. Some of our data augmentation capabilities are quite unique, and it's really easy to build pieces of code that would augment the data, what you're looking at. And of course, we have also things like possibilities to enable collaboration between users or developers, and all the enterprise things you would need for productionalizing your applications, such as security, audit, backups, scaling calculations, and so on. So it's a system that was optimized for data science, data visualization purposes, and it offers a lot out of the box, which could be customized. And customizations and using this platform and writing applications is the topic of our series. Here's the agenda of what we are going to cover today. So we're going to see what we can customize with the platform. We are going to cover functions in details, since that's one of the foundational concepts of the extensions. We're going to touch on the cross-language support. We are going to see how to package what we develop and how to connect to source code repositories. We are then going to take a look at our JavaScript APIs, and we'll touch base on how to customize and how to set up your developer environment. All right, so what can we extend in DataGrok? The answer is pretty much anything, really. You can introduce new functions. They could be either mathematical functions or something that has side effects. It could be a SQL query, a predictive model, a web service that is being added. We can even introduce things like file validator. So whenever a user drag and drops a file into a share, we can check in real time whether or not the file conforms to the expected standard. All sorts of parameter validations, completers, pretty much anything. And if some part cannot be extended out of the box right now, it's very likely that we can write that piece for extension, since we own the whole platform from the grounds up. From the very foundational level to the user interface, we can introduce changes on any level. So it's one of the unique advantages of our platforms. And what's great about that is that almost everything of what you see on the screen now, it gets extended as a function. And not only it gets extended in as a function in a uniform, clean way, these functions can also be developed in multiple languages. We've realized really early on that in order to build a no-compromise, really powerful system, we need to bite the bullet and provide support for first-class functions. And what is a first-class function? Well, in our terms, it's a function that can be inspected, and of course that can be executed, and that is associated with metadata. And on a parameter level. And yeah, think about a number of functions where each parameter has a meaning, or what we call a semantic type, and where each function could be categorized. So for instance, you can make a function that returns a viewer, where you would also say that it should only be available to, for instance, chemists. And this concept offers great flexibility in terms of what could be done with it. So the functions could be registered. That also means that we can iterate over all of them and find applicable functions to the current context. They could be inspected. So your, for instance, applications code can say, give me all the functions from the chemistry domain that calculate descriptors, or give me all the functions that accept a user as a parameter. And it's a really nice way not only to program, but to extend the platform, since the functions our custom package is developing will be used by the core of the platform and perhaps by other packages as well. So it's a really nice, coherent way for growing an ecosystem. We also use it for multiple other purposes, such as generation of the user interface when functions are getting explicitly invoked, or for things like logging, interceptions of calls. Sometimes you might want to cache results for the heavy computations based on the parameters and many other things. For instance, you might want to allow certain functions in certain contexts and disallow others. Or you might want to restrict your function to a specific audience. So it's a really important concept. So I'd like to stop here for a minute and maybe are there any questions about it?
I guess once you show us some examples, we'll have some questions, but right now it just sounds a little bit too abstract.
All right, yes. Thanks, Dima. There will be examples coming.
How's my microphone working? Can you actually hear me just fine?
Yes.
Oh, excellent.
All right. So not only we have that support for functions, but they could also be implemented in any supported languages. Currently, we support 5 of them. Well, technically 4, but JavaScript is different. So they could be implemented in Python, R, Julia, or Node.js on a server. So in this case, if a function accepts any data, any parameter, naturally, since we cannot execute it in the browser, the data will get sent to the server and will get processed there and then returned. And also, functions could be developed in JavaScript. They get executed right in the browser, so they get immediate sort of invocation mode. They don't depend on a server. It's typically fast. And as you know, nowadays, browsers are really powerful, so we can do a lot with it. And what's more, functions written in JavaScript get access to our Datagrok's JavaScript API and can take complete control of the platform. So we'll get to examples soon. And actually, this is one of the examples of a function.
So you're gonna scare everyone off, because very few people can actually understand what this thing is.
All right, maybe it's a little bit more complicated example than we needed at this place, but yeah, bear with me. So this is a function written in Python that accepts a representation of a molecule and returns a visualization of Gas-Tiger partial charges. So it might sound complex, but what you see on the screen is pretty much all about it. That's the whole function. So I just want you to stick with me for a moment, and you'll see how it all gets together. So here in this block is a regular Python code with a metadata on top of it. So the metadata defines the properties of a function and the properties for each of the parameters. So we have metadata on both the function and the property level. And in this particular case, it is saying that it's a function that has an extended name, has a description, here's the help for it, some tags, and the function accepts a string parameter, which is of semantic type molecule, and it returns some graphics that is called charges. And here in the function body, we operate with these parameters. So if you see, we construct a molecule from that string, I'll then do some manipulations with it, and then return charges. And now let's see if, what happens in the platform when how this function manifests itself. So let's open some chemical file. So that's a file with smiles, and now they get rendered as a molecule. Actually, So this is the way the data is stored in a file. It's a text file with this smiles molecule. And actually, the molecule renderer that you will see currently is also a function registered in a special way. So our platform picked up that function dynamically. It understood that it's a column with molecules, and it found the proper renderer as a function, and it is calling that function to produce that nicely looking molecule. Now let's get back to our Tiger partial charges. So when I click on a molecule, as you can see, it shows different, it's what we call info panels with different data augmentation. And one of the panels is called Gas Tiger partial charges. And actually, this is exactly what our function is doing. And actually, I can open that function right from here and see, well, that's the code that you have seen. So to me, it's pretty magical. We click on a molecule and something goes somewhere, queries different things, renders stuff, and the user sees different augmentations and projections of that data. And as you can see, it's really easy. And the way the platform put it all together is by inspecting that function, since it knows that there is an input with the proper semantic type, and the function has a tag panel. The platform does all of that at a runtime. And the result is pretty breathtaking to me still. It's really easy to write it.
We write a function that
Oh, I'm sorry. Is that a question? The audio is really garbled.
My question is, how does the function get in there?
Right. Good question. And that's the next topic, how they get there. So the function can get there in multiple ways. So first of all, it's possible to just go to scripts and say create a Python script, and you see a template. Essentially, it calculates number of cells, and here you can just modify it, click save, and it will get registered. And by default, probably it's only you will have access to it, but if you share it with others, others will start getting these information panels and stuff like that.
So for functions that are registered this way, where are they actually stored?
So they are stored in our database on our backend.
Are they version controlled, or it's basically just you like save them? It's like file system practically, so you get just one snapshot of that function.
It's pretty much a database. I believe we have some sort of version control, but actually for the proper version control, it's a lot easier to use packages and integration with the source control system, and we are going to discuss it right now. That's literally our next topic.
So for the metadata, is there a certain syntax? What happens if you misspell something, for example?
Yes, there is a certain syntax. You will likely get an error about the syntax. What I also want to highlight and recommend is that we spent really a lot of effort on making our help accessible. So you had a question about syntax. So actually right now we are showing a help on scripting. So I believe if you just scroll down, there will be a help with the proper syntax. Yeah, we also have a big online help where it's all described. It's probably not ideal at this stage, and I mean the help, but yeah, it's growing. And answering your question, you should get a warning if something is does not conform to our expected syntax. So yeah, once you register this function, it becomes available to everyone. Yeah, if you share it with them, and it's also possible to browse functions by going here, functions, and there are thousands of them. We should do a little bit of cleanup and categorization, which we intend to do in the next couple of weeks. So as you can see, functions could be anything, starting from mathematical ones, like arcsinus, and you can click on it and see where it came from, which package, where it's registered. It's also possible to simply run this function from here. And as I mentioned, we would generate the UI in real time. So if I want to add something, it just happened. For some reason, the result is not shown. And yeah, by the way, one of the features of functions is that they can get logged, so saved as macros, and they could be later reused. So that's the here in the console, we see that we've called Gus Tiger partial charges. So if we want to, we can simply copy and paste that thing and execute it. All right. So I'm diverging a little bit. So as we mentioned, a better way for packages, a better way to keep your source control under control is to use the source control system and integrate integrate Datagrok with source control repository. We do provide a Git integration out of the box, so you can set up your private package repository inside your own company and point Datagrok instance to that repository. And after that is done, the sources for different packages will be retrieved from there. We'll get to the question of what a package is and how to package content in 5 minutes. Yeah, I'll just say that this way provides completely managed experience, including version control, one-click deployment, and all sorts of statistics and analysis. So I realized that we also have a little more interactive demo with different scripting options. So one of our engineers, Vasily Nerozin, will show us how to use that scripting capabilities for multiple languages. So, Vasily, are you ready to take control?
Okay, sure. So you want to show me the multiple language support. So here in the data grok, we have a bunch of examples, as Andrei says. So we have a lot of different functions.
Vasily,
and
I think, so, sorry, I think you are not sharing your screen.
Okay. Okay, is it okay?
Yes.
So, for example, we can take the scripts written in R, and so let ask what you wanted to see. So I think I can show how to use different languages. Is it okay?
Yeah, sure. Yeah, we were thinking about an overview of using multiple languages, and perhaps multiple ways these functions get invoked. Yeah.
Okay. So, for example, so actually our scripts can be used in different ways. For example, it can be really small scripts, like, for example, test.
I'm sorry, are you showing something? I see the presentation.
I see his
I see
screen.
that
I can see the screen. This is Nick. I can see the screen okay. Go, Vasily.
Oh.
So, okay. So this is really simple script and don't work. Okay. So let's open some simple table. It's a Tesla stocks, I think. So it's a really simple test written in R. It's calculate velocity test, and just run it. And what we see in the console. Okay, so this is one way of using the our scripting in our system. So you can calculate the simple values and put there in whatever you want. So next step, is we can use this script as info panel, like Andrew showed before on gas target chargers. It's let's back to it.
So if you have a function that operates on the entire table, that entire table gets sent to the server, right?
Yes.
So in your experience, how does the performance look like? I mean, in terms of what are sensible limitations, how large that table can be that you can use this way interactively?
We testing. I think there are I think this can be 100 megabytes. But what I can mention that we're sending to our server in our optimal binary format. So usually 100 megabytes in a CSV form can be gigabytes even. So it's really how to tell, it really depends on the data types.
And actually, what is also interesting about it is that we are currently working on a sophisticated system of caching, where all our servers, application server and compute servers and others, will know exactly what the data set is that the current user is operating. So there will be no unnecessary transitions for the database, for the data snapshots. So for instance, if you retrieved your data from the database, say the complete Campbell structures, and you are starting to calculate descriptors on that, we will understand that, and we will use the snapshot that was already used for returning the data to the client in the first place. So for such calculations, we will not be incurring the data transfer cost. But it's in our plans. Disclaimer, it does not work currently.
Okay, let's get back to the Gestalt partial charges. I don't know what to add more than 100 told. So we can mark the script as tag panel, and it will show on the proper panel. And one more interesting is the ability to use a script as viewer. For example, we can have the scatter plot, for example, written in Python.
Yeah, scatter plot is probably not the best choice since we have a great
okay, let's close it and add something more interesting. For example, financial chart. Okay, it's really good for this data. So what the script, what we have there. So we have the special script that called financial chart and has the text viewers, and it returns the graphics. And we can embed this script into the viewer and use for the data and change whatever we want parameters. And as for the multiple languages support, all these things can be written in any languages that we support. So let me calculate the same ways using Python, for example. Have t-test and t-test written on Julia, Python. So for example, it's quite the same code, but written on the Python. Was there open and low? Okay, we have quite the same result.
Actually, maybe it would be a good idea to mention environments as well, since it's a popular question, and of course, everyone has a different environment or their custom library.
Sure. Scale, I think, and written on the Python. So we have support of the we have support for the environments. So it's a really general, usual problem that you have some libraries and you won't install it for your specific environment. So our example is a script is Telegram. It's using on Python and that used really specific libraries, the OpSpy and some signal processing libraries. What we can do is we can create a special file. So in the backend is a conda. So we're creating the conda YAML files with the environment start and put it into our repository with package. For example, Python scripts. And there we have environments. And I have Telegram environment that adds some Python 2.7 and custom libraries for the visualization. From the platform point of view, it will be script. There we just set environment, Telegram, and run it in this environment.
So at what point does the environment get instantiated? Is it when you actually run the script? Because say if you have tons of users each having multiple environments and you have like 100 environments, do they all are they all instantiated at the same time on the server side, or how does it work?
So it runs on the first script run, but the server would hold it, I think, 600 seconds, as I remember. Or we can extend this value after reboot of the server.
Because it can take a while to instantiate an environment, especially if you have tons of packages, for instance, in Python.
Yeah, but at the first time you should warm up it.
Mm-hmm.
Right, there is no way around it anyway, right, Dima? If, for instance, you are an application developer and you are exposing it to users, just warm up the environment before exposing it to users. It has to be installed at one point of time either way.
Yeah, definitely. Yeah, I understand. I just mean that if a user tries to run this and the environment has to be instantiated, then there should be some kind of warning. It's like wait till the environment is ready for the first use or something.
Probably, yeah, we are trying to give all sorts of visual cues to users in such cases, but yeah, we should do that if we don't already, I'm not sure.
Mm-hmm. All right, that's cool.
All right, thank you, Vasily. So should I take control back?
How do you actually prevent things from like colliding? Say if two different users try to create absolutely different environments with the same name.
At the moment, we don't have such checks, but we plan to use namespaces for the environment. And the platform will understood from what package and add this environment with the namespace of the package. But package names at the moment are unique.
Yeah, so Dima, we still have package names, so they serve as namespaces currently. So you can't have a script named the same way across a function named the same way across packages. Yeah.
All right, thanks.
All right, so I'm resuming then my part of presentation. So we stopped with packages, and Vasily also mentioned and showed the packages right now. And by the way, I hope everyone sees my screen. Okay, so I assume so. Well, there is a public repository of packages on Git that we maintain. It's on github.com datagrok AI public. It's also listed as one of the links. So check it out. We have some stuff here. So what we are currently referring to is a list of packages that the platform has access to, and it has an integration with it. So what it means is that at any point of time, I can go back to the platform and see exactly which packages are installed and inspect each of them. So for instance, that's a package that contains different open API specifications. We see exactly the version, where it came from, which repository, when it was updated or by whom, all sorts of different functions it exposes, and so on. It's really great. It's manageable and introspectable. You can see inside of it. We are also planning to make the experience even more seamless. So there will be a capability to browse the contents of the package interactively right from the platform, and perhaps even jump to the definitions of functions. So that sort of thing. In the next half a year, we will have a very strong emphasis on supporting our developers. So expect to have all those little improvements pop up very quickly. And of course, it's trivial to deploy a package. You can, if you played with the platform already, you probably know that we make heavy use of context menus and all sorts of drill downs. So by just right-clicking on an object, you see all the actions associated with it. For instance, a package could be republished, one of the actions, or it could be shared with an individual or a group and made available to a certain target audience. All right, now what exactly a package is and how we can put content in it. So a package is a unit of deployment for the Datagrok platform. So we designed it in such a way that it would be manageable and lightweight and standard. So in order to do that, we came up with a number of predefined folders. So it has some sort of predefined structure where you would simply put corresponding files. So for instance, for deploying scripts, you would put them under the scripts folder in your package. Open API files or swaggers go under swaggers, and so on and so forth. And you can put different things, including JavaScript code, CSS, and other things. And also, there are a number of standard files on the root level that describe the package. So let's take a closer look at one of the packages. It's called pedometer. It's our demo package for showcasing some advanced data augmentation capabilities. So what this package is doing, It contains a detector file which inspects all the tables that are opened in the system and marks the corresponding columns with the appropriate semantic types. In this case, it's a pedometer. So it finds columns that contain raw accelerometer signal and marks them as accelerometer for different axes. Then we have an analysis step, which is a Python code that uses digital signal processing techniques to detect the positions of steps in a raw biosensor signal in the accelerometer signal. And we have a code in the JavaScript that exposes a number of functions properly annotated, and then the data grok puts it all together. So let me just show you the end result, and I think it will click. So let's open a CSV file. Let's go to sensors, and that's our accelerometer file. As you can see, it's a raw accelerometer signal. We can already visualize it in multiple different ways. I don't know if that would make sense to analyze on scatter plot, or here's the line chart of acceleration, a histogram. So really a raw biosensor signal, and there are 80,000 rows in this data set. So what happened next? When I hover over a column, if you look at the bottom of the tooltip, it says that the quality, the semantic type of this column is accelerometer X. And how did the platform figure it out? So we've used, there's a special file that I mentioned, detectors, that gets executed whenever a new table appears in the platform, gets added to the platform. So in this particular case, it's a rather simple one. It just checks if it's a numerical column and it starts with accel underscore, and then it assumes it's an acceleration and marks it as appropriately. So that's what it is doing. Then let's see the result of other functions. So if I open the algorithms pane, there should be an algorithm called, actually it finds two appropriate things, speedometer and detect steps. So these are two functions that are part of the package.js and that are annotated appropriately. So here we are looking at the corresponding code. So one is pedometer, and it says that it's a function that accepts a number of different columns with the proper semantic types. And these semantic types were detected by our detector. And it will do something. So the platform matched the inputs of this function with the context, with the current context, with the table, and this is why it offered a user this particular analysis. So I find this concept extremely powerful. So it pushes the knowledge to the end users as opposed to the end users being forced to pull it. So if you think about it, normally a user would need to know that, well, somehow someone in the company has that sort of analysis that can count steps or analyze biosensor signal. But here we've inverted the responsibility. If a user is interested what can be done with it, he or she expands the algorithm pane, and you would see the actions and analysis that are appropriate in the particular current context. We already have thousands of multiple functions and analysis registered in the platform, and of course it will not be feasible to put them all here. So that's our way for only showing what is usable and actionable to the user at a given point of time. Another panel you see is a step counter on the right, and this is indeed another function in Python that was done in a very similar way to the Gas-Tiger partial charges that we've covered, so I will not go into the details, but essentially you expand it, it starts running, it calculated the number of steps. So really, we started with a raw CSV file, and now we get all that sort of augmentation where the platform knows what could be done with it. And for instance, if I run this pedometer analysis, that's a JavaScript function that takes control of the system. So immediately it opened a window that says the detected frequency and some additional information. And it also opened a line chart, which I can use for multiple purposes, I think. Yeah, I can select stuff on a line chart, and then in this particular window, it will tell me how many detected steps are in this region. So a very simplistic application, but it showcases the possibilities. And by the way, in the bottom, you see that steps column. So these are the steps that were detected by the Python code. And now let's take a look again at the package and the way we packaged it. So it's a tiny package. It has one script, as we promised. It's a Python script that we have used for detecting steps. And that's a detector we already covered. And two functions in this JavaScript code annotated appropriately. So this is it. If you are to develop an application, and that's a full-blown application already, right? Inobtrusive, it does not have a special entry point, but a contextually triggered application. That's all you need to do. Just write few functions that describe your intentions, and the platform will put it all together. I will also mention that we also have a concept of apps. So it sounds fancy, and we have an app store like a proper ecosystem should have. But in reality, an application is just a simple function that has a tag called app. This is it. It's a function. And if you think about it, it's exactly the same way it's done in different operating systems. Applications are essentially entry points, and you probably see parallels between packages and applications and functions exposed in DLLs and other executables. We took the same concept. It's a function that has an icon that can be launched. So there is no big distinction between application and function, except that typically it's something that has a visual representation. In the same manner, an operating system makes distinction between services and applications. We also do it in a similar way. Okay. Now let's take a closer look at the JavaScript API. JavaScript API is, well, JavaScript functions are special in such way that they can call our JavaScript API. And the API is a set of functions and classes that expose all the guts of our platform. And you can go either high level and invoke some sort of predictive models or query data sets or do anything else or send emails to users. And if you want to, you can really go lower, even including on a bit level and handle all the bit sets and data frames manually. It's really up to the developer. So currently not everything is exposed since the underlying technology of the platform is Dart. So we have to have that translation layer to JavaScript. We already exposed a lot, and yeah, this list is getting bigger and bigger every day. To figure out what the JavaScript API can do, there are multiple ways. So one of them is to follow our help, and of course we have the class reference and explanations of what it is. But also an easy way to figure out what could be done is by simply going to help JavaScript API examples. And here we have a collection of over 100 code snippets that demonstrate a particular aspect of a platform. For instance, how you access the data. Well, here's how I would load the CSV. And all of the snippets are executable. So not only they show the particular projection, particular part of the API, but you can execute them. So right now we've just imported that CSV file. Or this is how you would open a table by ID. Or this is how you would do custom rendering in a grid. This one did not work for some reason. Or that's how you would order columns. A really easy way to get familiar with what the platform can do. But also you can simply grab these snippets and paste it in your working code in your application. And of course, as I mentioned, we can always go to help. And let's search for what we have for JavaScript. And we have different things, how to develop team informatics applications with JavaScript, our description of the API, how to develop packages. So if you ever have questions, yeah, check our help or ask questions in the community. We intend to have most of the questions answered here.
So usually if you're not like intimately familiar with the API, it's kind of difficult to develop anything complicated because you have to like remember all the functions that you can use, their signatures, the objects, you know, the classes and all that stuff, you know. So and also you would need a good debugger and inspector. How do you usually like? What would be your recommendations for like debugging JavaScript code inside?
Great question, Diva. So as usually, we will cover it right in the next topic. That was the answer to your previous question, I think, as well. So that's exactly what Alexander will demonstrate, how to debug packages and how to essentially start from scratch and end up debugging a package in a couple of minutes. What I will just demonstrate is something really out of the box. So that's the browser. That's Chrome browser. That's its console. Our core object is grok, called grok. So you would type grok dot. You would see immediately what's available here. It has some balloon dot. It has what, info. Let's do info. Hi Dima. Boom. Done. So you can do it right from here. You would get a similar experience from your debugger since we ship the API. So you would get all the strongly typed, well, not strongly typed, but you would get the suggestions. And you can explore all the classes and methods and so on. It's always also possible to just start the JavaScript code, a sample, right? And you can paste stuff here and get a similar result. So now proceeding with the presentation and also answering your question. Yeah, we would demo the way to debug a JavaScript application. But before that, I just want to mention the whole idea of our applications, how they make development a lot better, easier, and faster. So as opposed to the traditional way of developing applications where you would build either from scratch or using some standard libraries, our approach is super lightweight. So in many cases, you would not need any traditional web services or data layers, since we can use the built-in functionality for both querying the data or appending, inserting the data in the database, and so on and so forth. We have complete control over security, role management, everything else. Many UI paradigms are built into the platform. Of course, high-performant viewers and others. For something heavy on the scientific side, we have support for Python, R, other languages, and actually using them is super easy. As you saw, it's just a matter of dropping Python or an R file in your package and deploying the package, and then you can easily use it either from the platform or call it from the JavaScript. So instead of deploying that sort of complex infrastructure, we can simply deploy little code snippets or scripts, and the platform will take care of the rest, including scaling the computations and suggesting applicable applications and functions to users. So in our understanding, it's a disruptive way for building applications on the web. All right. Having said that, and we do have 17 minutes left, I'll pass the control to Alexander Paramonov, who will take us through the development experience.
Oh, thank you, Andrew. Let me grab the screen. Can anyone see my screen?
I can.
Okay, I have some problems with Chrome. I will run a new window. Okay, can you see it?
Yes.
Super. A few things I should say before we start. We have two ways to publish the package. The first way is to set up a package location in external source, for example, in GitHub. And the second way is to deploy it with our upload utility from local machine. I will demonstrate a second path. So what we need to do to start developing packages from scratch, we need to download package template. This is an action in the package list. So when you click it, you will be prompted to select your operating system. I'll select Windows and I will name my package. Okay. Then the Datagrok gives me an archive with the package and utilities to deploy this package. I will extract them into empty folder. And let's take a look. This is a package folder. It contains Bootstrap for developing a new package. In the package.json, I see everything is filled down already. So I have a name of my package, version, and description. I'm free to change all of this stuff. And I have two files, package.js and detectors. So I can edit them and write any code I like. Second folder is utils folder. It contains two CMD files, one for upload for debugging and one upload for deploy. What does it mean? For each package, we have a bunch of published versions. So any package basically can contain any multiple versions. You can switch between them, and that means that users see only active version, and you can prepare, let's say, second version and test it and switch all users to it in a moment. And also, we have a concept of debug version that is only visible to the certain user. For example, if I load debug version of my package, only I can see it, and no one else can see it before I upload it as deploy. So let's start. Let's open this folder with ID. I use WebStorm, but any ID is okay, so you can use any ID you like. IDEA, Visual Studio Core, or something else. Okay, what we see here? We see here a simple function that calls alert with webroot value. Studio tells me that webroot is on result. What I can do? From this view, I can download API reference. And now everything is fine, webroot is recognized, and I can explore our API reference. Okay, let's deploy this package and start to use it. So all I need to do is run upload debug cmd, and that's all. Package is being deployed. Now I have to refresh the page, and I'll see the package, and I'm now able to run the function. Where it is.
So why isn't the API included in the template by default?
Just for your convenience.
Well, it may not be that convenient actually, because you had to add it separately, you know.
It can be deleted anytime, and you mean API? So okay. The problem is API is changing rapidly, and you don't have to download a new template each time you want to refresh the API reference.
Mm-hmm.
So you can, after we make a new release, you can refresh that API, and you don't need to download a package or something like this.
You had to make a copy. You copied it onto your working folder of that application, right?
Yes, That's
So
correct.
do we have to do that for each application?
No, basically I can place multiple packages here. So let me demonstrate. I can make another package. And that's all. I can debug packages at once. So when I upload it, second package is being uploaded to. And when I run upload, I get both packages uploaded. So can you, as you can see, I'm now debugging package Alex test2.
In this particular example, you're not using Git, right? That's basically just
no, I'm not using Git right now. I'm not using Git. If I want to use Git, I need to go to Datagroup UI and set up the Git path for here. So if I place a URL here, I'm able to publish the package from the UI, and package will get code from Git.
Yeah, but how do you so you say suppose you're developing your package in WebStorm on your local laptop, right? So then you run your deploy CMD, you know, and goes into where does it go actually? First it ends up in some location on the Datagroup server, and then you want to persist it in Git, so it becomes like two-step process, right?
So Dima, it's the other way around. You would typically push commit to Git and then just pull from Datagroup if you want to access to user. Yeah,
so
but for developers.
So if you're using Git, you do not use those deploy scripts, right? Deploy CMD.
You would use them for debugging, since it's convenient, right? You don't want to commit to Git every time you debug a new version of your application. But once it's ready for distribution, you would just commit it to Git, and that's it. You can set up your Datagroup instance to either, by the way, pull changes automatically, or you can pull them by request.
So essentially, when the package is being used from Git, at what point is it pulled from Git to the server when you do what?
When you press publish, it can be scheduled or it can be done automatically. But basically, you need to explicitly publish a package from the Git.
But if you say if you make changes and you say you upload new version to Git, how do you sync up with the published version? At what point does it happen?
Now it's been done manually, but we're working on webhooks, Git webhook support. So we would determine it somehow. By the way, you can set up a repository. It can contain multiple packages. So that's a repository for our public Datagroup API public, and it basically contains all the packages we have here. So when I press publish on repository, Datagroup goes to Git, downloads all the latest versions of all the packages, and publish it. And the way with upload utility is used to debug the packages. So let's try to debug something. As you can see, I made a lot of packages. So basically, I can debug them all simultaneously. So when I run upload debug, they all are being uploaded to the server. And when I update, I should see that I'm debugging all of these packages. Yes, as you can see, I debug Alex test something and demo. So when I run a function, I get an alert that's being coded there. And now let's try to debug it. So
do you need to be on the same server, or how does it?
that's a good question. Basically, in this utility, you can set up which server does it work with. If I set here dev, package will be uploaded to dev. And what about authorization? There is a small file, upload keys JSON, is being populated automatically too, but you can edit it anytime. Here is my dev key for public server. I can basically change it anytime in my user profile. Here it is. There's a link to change key, and I can copy it from any server. It is being used to upload packages. Okay, what we need to do to debug the package? We need to do is to connect browser and ID. I have already installed the plugin here from JetBrains, but it's basic stuff. I guess it's rather intuitive. So I add configuration for JavaScript debug. Where it is. And I set up URL. And what I need to do is to set up action before launch, upload debug. I've already set it here. That's simple too. It should just run upload debug utility, and that's all. Upload debug utility is rather fast. It wouldn't upload package if there are no files changed. So no change detected and no uploading, no publishing happened. Okay, let's try to run. Okay, cool, it works. And now I want to debug this function and make a breakpoint here.
Yeah, so Alexander, we have 5 minutes left, and I think you're at the end of your presentation already, right?
Just a single moment, just one minute. Yep. I run this function from console, and here I have a breakpoint here. Something terrible happened, and really the package couldn't load it. It was not intended, but you got to believe me, everything should work, and maybe I need to map my files. So here there's an utility in IDE that allows you to map files to your local sources.
Right. So essentially, it's a standard mechanism for that IDEs use for interoperating with the browser. You have to launch your browser from the IDE in a special way, and then you can place breakpoints and debug your code and even modify it on the fly. So you do get that sort of experience. Mm-hmm. All right. Thank you, Alexander, for the great demo. We have,
okay. Thank you, Andrew.
3 minutes left, so I wanted to. I'm not sure if we have time for questions, but we'll take some questions. I wanted to mention that we will upload both the slide deck used for today's presentation and the actual recording of the presentation to our community website, to the topic devoted to the meeting. So you are more than welcome to go check it out, ask questions. I think, yeah, asking questions there is a good way, since others will see it as well. So yeah, if there are any quick questions that we can answer in a few minutes, go ahead. And personally, I can stay a little longer, but let's see.
As an IDE, can we use Visual Studio Code?
So I've never personally tried it, but I believe yes. I think it uses the same actually mechanism as WebStorm is using for integrating with Chrome. All right. So yeah, if there are no more questions, thank you a lot for attending. It was great, yeah, to hear you. I hope to see you again. Please visit our forums. We'll announce the next demo that will happen in 2 weeks soon. So yeah, please give us your suggestions for what you want to be covered, and then we'll see how it evolves from there.
Thank you, Andrew. Everyone.
All right.
Thank you very much.
Thank you, everyone. Okay.
Bye.